Something came out of 3I Atlas that no one had a clean answer for. Not NASA, not the European Space Agency, not the teams of astronomers burning through telescope time on 3 continents. They watched the data come in, they ran the numbers again, and then they went quiet. The silence wasn't the silence of discovery. It was the silence of people who had expected one thing and received something else entirely. Something that fits inside the known frameworks of science? Barely. But only if you stretch those frameworks to their absolute limits. And some scientists are no longer willing to stretch. There's a moment in every great mystery when the facts stop being facts and start being questions. When the data in front of you no longer confirms what you thought you knew, but instead opens a door you weren't expecting to find. That moment happened to the global astronomical community on July 1st, 2025, when a telescope in the desert of northern Chile locked onto a faint point of light moving across the sky with a velocity that did not belong. The NASA-funded Atlas survey system, the same network designed to detect asteroids before they threaten Earth, had caught something it was never truly built to process. Comet 3I Atlas was discovered by the Atlas Survey Telescope in Rio Hurtado, Chile, and reported to the Minor Planet Center on July 1st, 2025. It was named 3I because it is the third interstellar object ever confirmed to pass through our solar system. Third, in all of recorded human history, with all of our telescopes, all of our satellites, all of our billions of dollars of orbital infrastructure pointed at the sky, we have found exactly 3 visitors from outside our solar system. And this one, the third one, turned out to be the strangest of them all by an enormous margin. Scientists determined that 3I Atlas was interstellar because of its high velocity and its trajectory. When it was first detected, it was already moving at approximately 137,000 miles per hour. That speed, combined with the unmistakable geometry of its path, told every astronomer who looked at the data the same thing. This object did not come from here. It did not originate in our solar system. It had not been orbiting our sun. It had been traveling through interstellar space, the vast, cold, near-empty gulf between stars, for an incomprehensibly long time before gravitational geometry and pure cosmic coincidence brought it into our neighborhood. And here is where the story begins to get complicated, because the more scientists looked at 3I Atlas, the more they realized that strange was an understatement. Think about what it means to have an object pass through your solar system from somewhere else entirely. It's not like a package delivered from across the world. It's a fragment of another planetary system formed around a different star under different conditions in a completely different region of the galaxy. Everything about it, its chemistry, its structure, its behavior, is a message from a world we have never seen and may never see. And the message that 3I Atlas carried was one that scientists are still struggling to decode, because it doesn't match anything in our existing library of cosmic knowledge, not even close. Previous interstellar objects revealed surprising diversity. Oumuamua behaved more like an inert rock, while 2I Borisov was rich in carbon monoxide and complex ices. Scientists had built a small but growing framework for understanding interstellar visitors based on those 2 data points. They expected 3I on Atlas to fit somewhere within that range. Maybe it would be more comet-like than Oumuamua. Maybe it would be richer in certain molecules than Borisov. What they did not expect was for 3I Atlas to blow past every established reference point and keep going. But here's where it gets worse, or more accurately, where it gets deeply, profoundly stranger. With only a few months to observe the comet before it retreated beyond view, scientists raced to collect data on this little world both before and after its encounter with our baking hot sun. Multiple telescope arrays across the planet were redirected. Observing. Time, some of the most competitive and expensive scientific resources on Earth, was reallocated. Teams from universities in Michigan, Chile, Spain, and across Europe scrambled to capture as much data as possible before the window closed, because they understood immediately that this object would not return. Astronomers have categorized this object as interstellar because of the hyperbolic shape of its orbital path. It does not follow a closed orbital path about the Sun. Once 3I Atlas left, it was gone forever. No second chances, no follow-up missions, no opportunity to ask more questions. The data they collected in those precious months is all humanity will ever have. And what that data revealed is something that shook the scientific community to its foundations. Let's start with the water. Not because it's the only strange thing about 3I Atlas, it is far from it, but because it may be the most scientifically significant. Astronomers using the Atacama Large Millimeter Submillimeter Array discovered that 3I Atlas is made of an astonishingly high ratio of semi-heavy water relative to water, indicating that its system of origin likely formed under conditions far colder than our own. Now, if you're not a chemist or an astronomer, the term semi-heavy water might sound like science fiction. It isn't. It refers to water molecules where one of the two hydrogen atoms has been replaced by deuterium, a heavier, stable isotope of hydrogen. The ratio of deuterium to regular hydrogen in a body of ice is, in effect, a frozen record of the temperature conditions that existed when that ice first formed. And the ratio in 3I Atlas's water is unlike anything scientists have ever measured. The water deuterium to hydrogen ratio the team measured on 3I Atlas was 40 times greater than that of Earth's oceans, and 30 times the average value for solar system comets. The unprecedented ratio tells scientists that the comet's home system formed in a place far colder and less irradiated than the molecular cloud that eventually became our solar system. Red. That again. 40 times greater than Earth's oceans, 30 times higher than the average comet in our solar system. The water DH ratio in 3I Atlas sits well above every solar system comet ever measured. Hale-Bopp, Hyakutake, Halley, 67P, and beyond what any known protostar or protoplanetary disk in our galaxy has produced. Every known protostar in our galaxy. This isn't a minor variation. This isn't a statistical outlier that can be chalked up to measurement error. This is a ratio so extreme that it doesn't exist anywhere in the catalog of known cosmic chemistry. It came from somewhere that our current models of star and planet formation cannot fully account for. Lead author Luis Salazar Manzano stated, "Our new observations show that the conditions that led to the formation of our solar system are much different from how planetary systems evolved in different parts of our galaxy." That sentence deserves to be unpacked slowly because it carries enormous weight. What Salazar Manzano is saying is that 3I Atlas is not just a visitor from another star. It is evidence that the process of planetary formation, the fundamental way in which worlds are made, operates differently in different parts of the galaxy. The universe is not uniform. The chemistry of existence itself changes depending on where you are. And 3I Atlas just handed us the first direct physical proof of that. It didn't come here to deliver a message in any deliberate sense, but it delivered one nonetheless. And this is where everything changes, because the water is only the beginning. 3I Atlas displayed an exceedingly high fraction of deuterium, amounting to 1 deuterium in every 100 hydrogen atoms in water, and 1 deuterium in every 30 hydrogen atoms in the organic molecule of methane. The measured abundances are up to 1,000 times above the average cosmic abundance, more than an order of magnitude higher than found in water in all known comets or meteorites, and 3 orders of magnitude higher than found in methane on solar system planets. 3 orders of magnitude. That's not a factor of 2 or 3 or even 10. That's a factor of 1,000 when compared to the methane baseline of solar system planets. The methane on 3I Atlas carries a deuterium signature so extreme that it defies the parameters of any planetary formation model that science currently has. This is not an anomaly within a framework. This is an anomaly that challenges the framework itself. And then there's the matter of its age. By studying ratios of hydrogen and carbon isotopes, a team led by molecular astrophysicist Martin Cordner of NASA Goddard Space Flight Center discovered that the comet formed somewhere very cold and very primordial, and maybe as old as 12 billion years. 12 billion years, our entire. Solar system is only about 4.6 billion years old. The universe itself is estimated to be roughly 13.8 billion years old. If the isotope analysis is correct, 3I Atlas didn't just come from another star. It came from the early universe. It was potentially born in the first few billion years after the Big Bang, when the galaxy was young and the rules of planetary formation were being written for the first time. This object is not a relic of another star system. It may be a relic of cosmic history itself, a frozen fragment from a time when the universe was young and the very chemistry of existence was still being established. The most recent interstellar visitor was crisscrossing our galaxy for some 10 to 12 billion years before it came near the sun. Let that travel through your imagination for a moment. While life on Earth evolved from single-celled organisms to complex ecosystems to intelligent civilizations capable of building radio telescopes and space agencies, while all of human civilization rose and fell and rose again across thousands of years, 3I Atlas was already ancient. It had already been wandering the dark spaces between stars longer than our planet has existed, and yet here it is. Here it came, passing through our solar neighborhood like a messenger from a time we can barely conceive of. But now we arrive at the part of this story that caused the loudest scientific argument in recent astronomical history, the part that split researchers into competing camps, generated hundreds of papers, filled conference halls with heated debate, and put one of Harvard's most prominent astrophysicists directly at odds with the mainstream of his own profession. Because the water chemistry, extraordinary as it is, was not the only thing coming out of 3I Atlas that scientists couldn't explain. NASA's Hubble revelations describe 3 symmetrical jets emanating from 3I Atlas, defying easy explanation, yet potentially explainable through exotic gas dynamics. 3 jets. Not 1, not 2, but exactly 3. And not arranged randomly, not scattered across the surface at irregular intervals, but positioned with a geometric precision that made multiple scientists stop and look twice at the images. The 3 mini-jets are separated by 120 degrees from each other in sky projection, and are supplemented by a 4th anti-tail jet extending in the sunward direction. 120 degrees. Exactly. 3 jets, equally spaced, forming a perfect triangle of propulsion around the nucleus of the object. And this pattern appeared not once, not in a single image that could be dismissed as an artifact, but persistently across dozens of observations. The 3 symmetric jets appear persistently in the Larsen-Sekanina filtering of 24 images taken by the Hubble Space Telescope on November 30th, December 4th, 12th, 27, 2025, and January 7th, 14, 2026. 24 separate images, consistent, repeatable, unmistakable. Harvard astrophysicist Avi Loeb, a scientist whose career has been defined by his willingness to follow the data wherever it leads, regardless of whether that destination makes his colleagues uncomfortable, looked at those images and raised a question that the establishment immediately tried to close down. The symmetric configuration of 3 jets plus the anti-tail jet raises the question of whether they might constitute a technological system designed for stabilizing the trajectory of 3I Atlas. He then went further, citing a paper by Beau-André, which showed that the minimal approach for steering an interstellar comet along a controlled trajectory indeed matches this 3+1 jet configuration. By relaxing the full 6 degree of freedom control to forward cone steering, sufficient for practical navigation, the paper showed that 4 thrusters are required. 1 primary jet and 3 secondary jets separated symmetrically by 120 degrees from each other. 4 thrusters. 3 symmetric, 1 primary. Exactly what the Hubble images show. And this is where the debate stops being purely abstract and starts becoming deeply, uncomfortably concrete. Loeb told the Harvard Crimson, "Nature doesn't do perfect symmetry." His critics responded immediately. Jason Wright, a professor of astronomy at Penn State, argued, "We know that outgassing can create weird rotation. We know jets can appear symmetrical due to the rotation of the nucleus. And that is the nature of the debate in its purest form. On one side, scientists pointing to known natural mechanisms that could, under specific conditions, produce what appears to be symmetry. On the other side, a scientist pointing to the cumulative weight of anomaly after anomaly, arguing that the threshold for natural explanation is being asked to carry more than it can bear. What most people are not seeing is that the question was never simply about the jets in isolation. It was about the jets in the context of everything else. 3I Atlas was identified with 18 anomalies by Avi Loeb, ranging from its nickel-rich outgassing and extreme deuterium levels to the symmetric jet system and unusual rotation axis alignment. 18. Individually, each anomaly might have a natural explanation, but 18 anomalies stacking on top of each other, each one pushing the object slightly further outside the boundaries of what natural cometary science predicts. That is a different kind of scientific problem. Before perihelion, the plume of gas around 3I Atlas featured nickel with much less iron, as found in industrially produced nickel alloys, and after perihelion, it featured methane, a biosignature whose volatility lies between carbon dioxide and carbon monoxide, both of which were well detected before methane. Methane, a biosignature, in an interstellar object, emerging in a specific chemical sequence that followed a logical progression. The word biosignature does not mean proof of life, but it does mean that the molecule in question is one that, on Earth and in our current understanding of chemistry, is associated with biological processes. Its presence is not proof of anything, but its presence is not nothing either. And then there is the matter of the rotation axis. At large distances from the Sun, the initial rotation axis of 3I Atlas was aligned to within 8 degrees with the sunward direction when it entered the solar system. 8 degrees. That is nearly perfect alignment. For a natural object, tumbling through interstellar space for billions of years, to arrive at the edge of our solar system with its rotation axis pointed almost exactly at our Sun is statistically extraordinarily improbable. Not impossible, just extraordinarily improbable. And that is the word that keeps coming up in this investigation, in context after context. Anomaly after anomaly, improbable. Every single feature of 3I Atlas is, on its own, within the range of possible natural outcomes. But the probability of all of them occurring together in the same object is a number that gets very small very quickly. One team of scientists, led by Xavier Perez-Cudo of the University of A Coruña in Spain, traced the path of interstellar object 3I Atlas back 10 million years. 10 million years of backward trajectory calculation, a staggering computational undertaking, trying to identify what star system this object originated from. The galactic neighborhood through which 3I Atlas traveled is vast and complex. Stellar positions shift over millions of years. The task of tracing an object's path backward across that kind of timescale is not simple. And even after that enormous effort, the object's precise origin remains unclear. We know the general direction it came from. We know the constellation Sagittarius marked its arrival point, but we do not know exactly which star birthed it, or what that star's planetary system looked like, or under what circumstances this ancient fragment of ice and chemistry was ejected into the galaxy to begin its multi-billion-year journey. The real story is that we are dealing with an object whose origin we cannot fully determine, whose chemistry breaks our existing records, and whose structure keeps producing questions faster than we can answer them. The scientific establishment, to its credit, did not dismiss these anomalies without investigation. The Breakthrough Listen initiative, together with its network of collaborators, undertook observations of 3I Atlas using a variety of facilities worldwide, starting shortly after its discovery and continuing through its closest approach to Earth. The Allen Telescope Array was pointed at it within days of discovery. The Green Bank Telescope, the world's largest steerable single-dish radio telescope, was aimed at 3I Atlas less than 24 hours before. Its closest approach to Earth. Scientists scanned across a wide frequency range looking for any signal, any transmission, any trace of artificial electromagnetic emission. No artificial radio emission localized to 3I Atlas was detected. And on the surface, that sounds like a definitive answer. No signal, no technosignature, no evidence of alien technology. Case closed. But informed sources within the research community point out something important that the headline conclusion tends to obscure. The absence of a detected radio signal does not mean the absence of technology. A probe that is dormant, or that uses a different form of communication, or that simply is not transmitting during the window of observation, would produce exactly the same null result. The Green Bank telescope is extraordinarily sensitive enough to detect a transmitter as weak as a fraction of a watt at that distance, but that sensitivity only applies to radio waves. The absence of signals doesn't rule out dormant technology, as the more unconventional researchers in the field have continued to argue. The debate did not end with the radio silence. It deepened. Meanwhile, the object itself was not standing still. 3I Atlas made its closest pass of the Sun on October 29, 2025, and then began heading out of the solar system. On December 19, 2025, 3I Atlas reached its closest distance to Earth at 1.7 astronomical units, approximately 167 million miles. That is roughly the distance between the Earth and Mars at its farthest point, close enough for the most detailed observations of its entire solar system passage. And yet, even at that closest approach, with the most powerful instruments on Earth and an orbit pointed directly at it, 3I Atlas still refused to be fully understood. The closer scientists looked, the more questions they found. The more data they collected, the more anomalies accumulated. This is not how science is supposed to work with natural objects. Natural objects, when studied more closely, become clearer. They fit into known categories more precisely. The picture sharpens. With 3I as in Atlas, the picture kept getting stranger. As interstellar comet 3I Atlas began moving away from the Sun in December 2025, astronomers took the opportunity to turn NASA's James Webb Space Telescope on it, collecting its first mid-infrared chemical fingerprint of an interstellar object. The Webb telescope, the most powerful space observatory ever built, was designed to peer into the earliest moments of the universe. Turning it on 3I Atlas was a once-in-a-lifetime opportunity to extract chemical data at a level of detail never previously achieved for any interstellar visitor. What the Webb data revealed added yet more complexity to an already extraordinarily complex picture. 3I Atlas adds yet another chapter to the growing cosmic story, a dust-rich body that reveals molecular signatures in ways that blur the line between familiar cometary behavior and new physics. New physics, not known physics applied in unusual circumstances, not familiar mechanisms operating at an unusual scale. Actual new physics, behavior at the molecular level that challenges the existing models. According to informed sources tracking the research pipeline, the full analysis of the Webb data is still being processed and cross-referenced against ground-based observations. The papers coming out of that analysis will likely reshape our understanding of interstellar chemistry in ways that the scientific community is only beginning to anticipate. The data from this single object, this one visitor from the distant universe, is generating a volume of research that will take years to fully absorb. And here's the thing. that keeps the most thoughtful astronomers awake at night. 3I Atlas is already leaving. It left. By the time these words are processed and absorbed, 3I Atlas is already beyond Jupiter's orbit, fading into the outer darkness of the solar system, on its way back to the interstellar void from which it came. 3I Atlas will never return. The window is closed. What we have is what we have. And what we have is a collection of data points that, taken together, paint a picture of an object that should not exist as it does. Not by any model of planetary formation or cometary chemistry that our civilization has constructed across centuries of scientific inquiry. What most people are not seeing in the reporting about 3I Atlas is the scale of what this discovery actually represents. This is not simply the third interstellar object to pass through our solar system. This is the first direct chemical sample, the first measurable, quantifiable data from a planetary system that is not our own. Every comet, every asteroid, every piece of material we have ever studied before came from within our solar system. Every sample return mission, every spectroscopic analysis, every isotope measurement was measuring chemistry that originated around our sun. 3I Atlas changed that permanently. This marks the first time scientists have successfully performed this type of water analysis on an interstellar object. The techniques developed to study 3I Atlas, the measurement protocols, the analytical frameworks, all of that is now a permanent part of science's toolkit, ready to be applied to the next interstellar visitor when it arrives. And that raises the next question that scientists are quietly wrestling with, because the arrival of 3 interstellar objects in just 8 years, Oumuamua in 2017, Borisov in 2019, and now 3I Atlas in 2025, suggests something important about the density of interstellar objects moving through our galactic neighborhood. Given the small number of such objects known, only 3 to date, thorough study of each one is warranted, but the rate of discovery is accelerating. Our survey systems are improving. Our detection capabilities are growing. The Atlas network that found 3I Atlas, the Vera Rubin Observatory coming online, the next generation of sky surveys, these systems will find more. The question is not whether more interstellar visitors will be detected. The question is what they will look like, whether they will fit neatly into the category of natural object that the establishment wants 3I Atlas to occupy, or whether, one by one, they will keep pushing the boundaries of what that category can contain. The real story here is not about alien technology. It may not be about alien technology at all. The real story is about the limits of human understanding and what happens when the universe presents us with data that doesn't fit inside the boxes we've built. Science advances precisely in those moments, when an anomaly refuses to be explained away, when the data keeps pointing in a direction that the existing framework cannot accommodate, when scientists are forced to either build a new framework or admit that the old one is incomplete. 3I Atlas is one of those moments. It arrived from the ancient universe carrying water chemistry that breaks all our records, methane that behaves like a biosignature, jets that are geometrically precise in a way that natural processes struggle to account for, and a rotation axis aligned with our sun in a manner that is statistically improbable. And then it left. Quietly, without ceremony, without resolution. As 3I Atlas races back out into the dark, currently passing the orbit of Jupiter and fading from view, we are left with an uncomfortable ambiguity. The data is messy. The 3 jets could be a trick of the light, or they could be the exhaust of a defunct probe. And that discomfort, that uncertainty is not a flaw in the science. It is the science doing exactly what science is supposed to do, refusing to claim certainty where certainty does not exist. The honest answer, the only intellectually defensible answer, is that 3I Atlas is an object we do not fully understand. It behaves in ways that require explanation. The explanations offered so far, both the natural and the extraordinary, remain incomplete. The team presented 3 possible explanations for the extreme deuterium ratio in 3I Atlas's water. It was established during a cold, dense prestellar cloud phase before its host star formed. The host disk did less thermal processing and retained a higher deuterium ratio, or 3I Atlas, formed unusually far from its host star, beyond the carbon dioxide snowline where water ice forms in more deuterium-rich conditions. Of the 3, the authors consider the prestellar cloud explanation most likely. Most likely, not certain, not confirmed, most likely. And most likely, when you are dealing with an object this strange, is a phrase that should keep everyone's options open. What happens next is, in many ways, more important than the discovery itself. The data from 3I Atlas will be analyzed for years. Papers will continue to emerge. The debate over its nature will continue. There's a quiet, nagging thought that keeps even the staunchest skeptics awake at night. And the next interstellar visitor, whatever it looks like, whatever it carries, will be studied through the lens of what 3I Atlas taught us. Our instruments will be sharper. Our analytical frameworks will be more sophisticated. Our understanding of what to look for will be more refined. The universe has been revealing itself to us slowly, one anomaly at a time, across the entire history of human scientific inquiry. And every now and then, it sends us something that accelerates that process, something that forces the question, something that makes us look up at the dark sky between the stars and ask what else is moving through it that we haven't noticed yet. 3i Atlas is gone. The data it left behind is permanent. The questions it raised are still open, and somewhere in the galaxy, in the vast cold distances between stars, other objects are moving. Some of them may be heading in our direction. Some of them may arrive in our lifetimes, bringing their own impossible chemistry and their own unexplained geometry and their own challenge to everything we think we know. And when they do, we will be ready. But ready for what, exactly, is still a question that no one, not NASA, not Harvard, not the most sophisticated telescope arrays ever built, can yet answer. That might be the most important thing 3i Atlas told us. Not what the universe contains, but how little of it we actually understand.